Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. Let's look at how we find the area between two curves, where one curve is below and the other above the x-axis. The diagram on the board shows two curves, and the red shaded region is the area we want to calculate. The equation of each curve is shown. We have the curve above the x-axis as y equals x cubed plus 1, and the curve below the x-axis we have as y equals x cubed minus 2. And for this example, we're going to find the area between the interval x equals 0 and x equals 1. Let's now look at each of the curves between the limits of x equals 0 and x equals 1. So for y equals x cubed plus 1, the area between the limits of x equals 0 and x equals 1 and under the curve is shown by the blue shaded region. And for y equals x cubed minus 2, the area between x equals 0 and x equals 1 and under the curve is shown by the green shaded region. If we now subtract the green shaded region from the blue shaded region, we find the area between the curves shown in red. I can now hear you scream, "How can this possibly be true, John?" And understandably so, as this is not intuitive. So let's take a look at why this is so. The area of the blue shaded region is a positive value, as the area is above the x-axis, and the area of the green shaded region is a negative value, as the area is below the x-axis. So subtracting the green shaded region from the blue shaded region effectively adds the two areas together, as two negatives make a positive. Now, to find the area of the blue shaded region, we can integrate the function y equals x cubed plus 1 between the limits of x equals 0 and x equals 1. Using the power rule to evaluate this, we get x to the power of 4 divided by 4 plus x, and we need to evaluate this between 0 and 1. So if we plug in these limits, we get 1/4 plus 1 minus 0, and this evaluates to 5/4. And similarly, to find the area of the green shaded region, we can integrate the function y equals x cubed minus 2 between the limits of x equals 0 and x equals 1. And using the power rule, this evaluates to x to the power of 4 divided by 4 minus 2x. And plugging in the limits of 1 and 0, we have 1/4 minus 2 minus 0, which equates to minus 7/4. So now, the area of the red shaded region is the area of the green shaded region, which evaluates to negative 7/4, subtracted from the area of the blue shaded region, which evaluates to positive 5/4. So we have 5/4 minus 7/4, which gives us 12/4, and therefore the area of the red shaded region is 3 units squared.